笑啊，就没有人，然后就
练习啊，
讲给两位啊贵宾 VIP
好，
开始吗？
好，可以。
Good afternoon, dear judges. My name is Shirin Wu. My topic for today is immune reactions of encapsulation in cockroaches. As you may know, it is generally believed that there is no obvious acquired immunity in insects. They prevent pathogens from spreading only by hemocytes encapsulation to code foreign objects. My research counters this idea by investigating the immune reactions of encapsulation in cockroaches. And I found that insects, or cockroaches specifically, have self-non-self recognition and the immunological memory. I hope that one day they can become an animal for clinical studies. To find out the immunological reactions of cockroaches, I implanted antennae and foreign objects into a cockroach's body and record the degree of the immune response by observing the size of the capsule in the whole experiment. My first experiment was to find whether cockroaches have self-non-self recognition. I implanted self and non-self antennae into a cockroach at the same time, and I found that the encapsulation caused by non-self antennae were obviously stronger than the self ones. We can see the difference clearly from these two pictures, so I can infer that cockroaches have self-non-self recognition. Looking at the figure of the right, we can see that the significant difference between the encapsulation caused by self and non-self antennae had already shown by 9 minutes, and by 15 minutes it slowly becomes stable. Therefore, the reaction durations of all subsequent experiments are 15 minutes. Next, as clinical studies often require carbon dioxide for anesthesia, I would like to confirm whether anesthesia by carbon dioxide would affect cockroaches' immune response. After this experiment, I certified that carbon dioxide anesthesia has no effects. As I suspect that surface proteins plays an important factor when recognizing self and non-self, so I let the antennae contact with alcohol before implanted into a cockroach to let this surface protein denature. Then I found that the difference between the encapsulation caused by self and non-self antennae were unable to be distinguished. So I'm sure that surface protein do play an important role when recognizing self and non-self. With the above investigations, I certified that cockroaches have self-non-self recognition, not interrupted by carbon dioxide, and surface protein do play a very important role. And I asked myself, as cockroaches can distinguish self and external objects, do they perform memory effects to objects implanted again? So I tested this by implanting the antennae for 15 minutes before removing, measuring, and cleaning. This process was repeated 3 times. Then I discovered that the encapsulation cost had decreased obviously. I think it is due to the gradual depletion of the hemocytes. Therefore, in the third implantation, they didn't have enough cells to cover the foreign objects. So I improved my experiments. I let the cockroach make contact with small foreign objects first. Then I implanted the antennae to survey the memory effects on encapsulation. I first removed the tibia and the tarsus from the cockroach's leg. Then I implanted the tip of a cockroach's antennae into the femur. 3 days later, the rest of the antennae were implanted into the cockroach to survey the memory effects. After this experiment, I found out that if the cockroach had made contact with non-self tissues, the encapsulation cause would become much stronger compared with the original non-self ones. And if the cockroach had made contact with self tissues, the encapsulation cause would become no difference compared with the non-self ones. But if the cockroach had made contact with both self and non-self tissues at the same time for 3 days, the encapsulation cost would decrease obviously. So I think that cockroaches do have immunological memory, and it includes enhancing effects and inhibitory effects. So I made 3 inferences about the physiology functions of the inhibitory effects. The first inference is that when too many foreign objects invade its body, cockroaches will suppress the immune response which could consume too much hemocytes. The second inference is that when facing various foreign objects, cockroaches will lengthen the time to identify each invader to establish its immunological database. The third inference is that cockroaches will suppress the immune response which could lead to autoimmunity. Then I also wanted to know whether the encapsulation is reversible. Written in the paper, I have already known that positive electrodes will enhance encapsulation and vice versa. So I implanted positive electrodes and negative electrodes into a cockroach at the same time. I exchanged the electrical charge without removing the copper wires. Then I found that the capsule on the positive electrodes didn't decrease after I exchanged its electrical charge into negative. In fact, it increased continuously. So I think that there are only additive effects in cockroaches encapsulation. It's not reversible. Next, to compare the effects of gender on encapsulation, female cockroaches were added in this last experiment. As males' cockroaches' antennae original width are wider than the females, I converted the capsule's maximum width into cross-sectional area to make the comparison. Then I found that no matter by self or non-self antennae, the encapsulation produced by females were obviously stronger than the males. I think it is due to the female's relatively heavy weight, which means it contains more hemocytes. Females may also have the mission of breeding, needing a more severe reaction to foreign objects to ensure the safety of their future generations. To sum up, my research has certified that cockroaches have self and non-self recognition and immunological memory. Maybe one day they can replace mammals like mice, rabbits, etc. in clinical studies and stand a very important role in the medical field. That's the end of my presentation. Thank you very much for listening. If you have any inquiries, feel free to ask me.